Hi, everybody, and welcome to AI Office Hours with Cognite. My name is Gabe Prado, and I'll be moderating our panel today. Over the last year, the industrial data and AI landscape continues to change very quickly and can seem to get a little bit more complicated. At Cognite, we are always getting questions about terms and technology, and so we wanted to take a little bit of time to answer these in an informal setting. Today and over the next several weeks, we're going to have a series of short videos with topics ranging from what is an AI agent to the role of why do I need my data in context to what types of agents are even being used today in that industry. And our goal with this entire series is really to help keep you up to speed on what matters. That way you can meet your data and AI goals by the end of the year. So without much further ado, I'd love to introduce our panel. Jason, can you tell us a little bit about yourself?
Sure. Jason Shern, I'm the field CTO for Cognite, and I spend most of my time providing advisory to our customers and partners and how they can maximize the value they get out of their data and generative AI.
Fantastic. Great to have you here. Milad.
Hi, everyone. My name is Milad. I work as an AI architect here at Cognite, essentially working with the AI services that we have in Cognite Data Fusion.
Fantastic. And last but certainly not least, Vibha.
Hi, I'm Vibha Srinivasan. I'm VP AI Engineering, and I lead a team of engineers in Austin. And we are focusing on building industrial agents, and we'll get to what they are, I guess.
Fantastic. Well, great to have you all here today. I'm excited about the conversation. And one of the questions we get a lot, and there may be a little bit of confusion about, is we hear about co-pilots, we hear about chatbots, and now industrial agents. Can you help us explain what are industrial agents?
I can give it a try. So I think the simplest definition I can provide is that an industrial agent is essentially an entity powered by a language model that you can communicate with to solve a specific business problem. So it's a very simple, but perhaps a bit high-level definition. So it can be useful to also consider what's actually inside an agent. What does it consist of? And there are a couple of components. So one is, of course, the language model itself with reasoning capabilities. It has a set of instructions describing how it should go about solving a specific task. It has access to a set of predefined and specialized tools for industry. And finally, it has access to industrial data as well as the context that the user is in. Now, as you know, like the concept of agent has been around for quite some time. This is nothing new, but obviously it has gotten a lot of attention recently with improvements in large language models combined with the cost of using them that has been decreasing. And naturally, when more general tools such as ChatGPT was released, many people, including us, try to use them on domain-specific tasks. And a key learning has been that it doesn't really work, especially if you want to build something that goes beyond, a fun demo, and especially not in a heavy asset industry where it's a very complex domain, both in terms of the data that is involved, but also the problems that you are trying to solve. So that's why I want to highlight that an industrial agent is specialized. It's not made to solve a broad range of tasks halfway, but rather to solve one task or specific task very well. And this is something that is reflected both in the tools that it has at its disposal that allow it to communicate with the external environment, but also the way you measure the quality of these agents, where we have industry-specific data sets that are representative for real life when these agents are being used in industry.
Hey, Milad, I like that summary, and you mentioned that an agent can take advantage of tools that interact with the external environment. Could you elaborate on that a little bit? What does that look like in practice?
Sure. I mean, you can have different categories of tools, obviously. But just to give you an example, you can have tools that help you look up data using the knowledge graph. So we have, for instance, tool in Cognite Data Fusion that allow you to look up sensor data from a given equipment. Another example is specialized tools to look up industrial documents and extract relevant information from them and present it to the language model in an LLM-friendly way.
Viva, anything you would like to add?
Yeah, I really like that you highlighted the fact that these are not generic, and like an agent is specialized for a task. And I want to build on that and say, while it is specialized, I think one difference from like when you look at other like industrial automation software that's been around is that they are still very flexible within the scope of that task or within that use case, meaning that they're really designed for human interaction. Like if you think of like standard automation, they work with inputs in a certain format. They are designed to give you outputs in like a very strict format, and there's really minimal human intervention there. So it's used when you have to do like very repetitive tasks, like you're transforming data from and moving it from like one source to like another, like a destination, processing invoices, things like that, very repetitive tasks typically that you would run on a schedule. And the difference between that and an agent is like with an agent the human interacts, and depending on what the human wants to accomplish, like within that scope, this agent, and you spoke about tools, it can decide like which tools to use and like what the user is really trying to get out of it, and sort of reason through that, build a plan and execute accordingly. So yeah, that's something I just wanted to add here.
So it's like task automation on steroids a little bit. But when you think about it though, agents can process a request, but they're not this sort of rote rule-based way of processing that request. There's reasoning involved. Just like we as humans, when we go and we proceed to accomplish a task, we know what we're trying to go do, but we're applying reasoning along the way to go get that task done. And that's sort of the power of an agent. It allows for a level of adaptation to the request and the inputs, but still within the broader guidelines of the design of the agent. And so that allows you to be able to not have to redefine every possible scenario that this agent will address, but you can define the broad guidelines that this agent will be successful in completing for a user. And it can even learn from these interactions over time to improve its responses. So I guess, in summary, an industrial agent, typically one powered by a large language model, is really about solving a specific business problem, but doing it in a deep, focused way with reasoning that allows you to be able to have a more human-like interaction with your industrial data to accomplish the task that you're assigned to go do.
I really like that summary. I think it's easy to get overwhelmed by, okay, new term, new everything, but I think that's a very clear depiction of how industry needs to be thinking about it. And I guess it kind of leads to the next question. There are probably some skeptics, but who are thinking, do we really even need industrial agents? Is this more of the Gen AI hype and the machine learning hype, or are these something that are going to be around for a while, right? Are these here to stay?
I think that these are absolutely here to stay. There's a tremendous amount of value that we can gain from these agents, from the power of these agents that are just either extremely difficult, costly, or just too difficult to do in any other way. And yeah, I'll give a very simple example. We have a customer that we're working with that has a challenge in processing the documents they receive from their suppliers. So imagine a large oil and gas company, an energy provider that has large assets that receive, technical documentation on all of the equipment within that asset from literally hundreds of suppliers. And they tried early on to force all of those suppliers to provide that documentation in a very consistent format. And at the outset, they all agreed, oh yes, we'll do this. They win the bid, they start the project. And then when it's time to get the documentation, they're all getting the documentation in the standard formats that those suppliers have always provided that documentation. And so they say, hey, what gives? I said, well, this is what we can do now. If you want it to be exactly like you said in the contract, it's going to be another 6 months. Well, they couldn't wait for that. And it's nearly impossible to go and program something that can account for every possible variant of technical documentation you might get from a supplier. But humans can do this because we can reason. We can look at these different versions, and I know this information is the maximum design pressure value, and this information pertains to some other aspect of the equipment that I need to extract and put into my data models to be able to effectively search and use that information across my enterprise. Well, this is great. This is a perfect example of an agent use case where I have a specific task I need to go accomplish. I need human-like reasoning to be able to go do it. And so I can use a large language model to look at these documents. I can tell that large language model, this is your job. This is what I need you to do. Here's the information I need you to find within these documents. And here's how I'd like you to return that information to me. It's almost like if you took a new graduate or an intern, you could give them those instructions and they could use their own reasoning to go accomplish the task. And that's what an agent is. I can go develop a doc parsing agent, which is what this energy company did, that is able to process hundreds of thousands of these documents that are not consistent and still be able to consistently and with a very high level of accuracy, retrieve the relevant information from those documents, place it into their data models that they can now use to search and to be able to apply to other business processes that they have. And so that ability for us to finally be able to apply human level reasoning to a task is a type of automation that I don't think we've ever experienced, because in the past, we always had to know every possible scenario and account for every possible scenario and program that in. Now I can say, look, I can give you broad guidelines. I can give you instructions. I can tell you what data is available for you to go do your job. Now I would like to use your reasoning engine to go accomplish that task. And so these industrial agents really bring the power of generative AI and machine learning and other capabilities directly to the challenges and tasks that are unique to industry and specific to each organization. And so I think this is really going to be crucial in improving decision-making processes and helping organizations achieve a higher level of productivity and safety much more quickly and at a much more effective cost profile than they could have ever hoped before. And in fact, a lot of these agents are accomplishing things that frankly would just be unautomatable in the past.
It sounds like you're very bullish on this. I'm excited.
I am.
Malad, any thoughts there? What do you think?
No, I think Jason covered it well. It's really, these days this time is amazing. I mean, we are now able to solve problems that, as Jason said, were impossible before. So I think there are a lot of opportunities here, but also challenges that needs to be covered. And there has been, I guess, some failures and some learnings there. That has been important.
Do you have some examples of, I know this is kind of the second phase of generative AI, but do you have some examples of, what did we learn in the first round and what are we doing better this time?
Yeah, absolutely. So I think you have kind of different categories of challenges. Some are technical, some are more cultural and organizational. I will focus more on the technical aspects and let the others speak to the rest. So if we look at the core, one of the perhaps major issues with agents in general, not only industrial agents, has been robustness. And that's because large language models, they are non-deterministic inherently. And in a way, they are designed to be creative, unlike like a search engine, right? And because of that, when you incorporate these models inside solutions such as agents, you may end up with many failure modes, which will, of course, hurt your robustness. So to handle these failure modes, it's very important to have a systematic approach, because if you don't have that, you will fix something but break something else. And I have seen that some people spend a lot of time making changes to the system, but very little time on measuring the impact of those changes. And obviously, it's very hard to make real progress in this manner. So what we are doing at Cognite is to invest quite heavily into evaluating and measuring the quality of the systems that we are building. And as I mentioned earlier, we have data sets that have been created specifically for industry, because we want them to work well on industrial use cases. And having data sets that are representative for real life is very important. And it's not an easy task. It takes time and it's very hard, but we believe that it's really key to make solutions that are robust, that actually work.
Absolutely. And Viba, have you seen any of these examples, or do you have an example of what used to be hard with an agent that has now become easier or less challenging? Any examples to add to what Milad said?
Yeah. So like, even if I look at the example that actually Jason gave before about like parsing sheets, if we take that, like earlier, our approach to that would be kind of doing something based on the format of the document, as in, like you said, the same information could be like available as like notes, like someone had written that up, or like it is like in a nested table, like a table within a table containing that. It could be like a row kind of thing. There are like so many different formats. So we would do something like, trying to design a model that took in, the sheet in a certain format, then work with that and extract the values that we needed. Now, with like, agents and the power of LLMs, we can give it, some guidelines and some instructions, and then it is able to, because it's already trained on a lot of data. And if you choose to, you can additionally like train it on like more industry specific data or domain specific data, but it is able to handle these situations much more easier. Whereas before you would be like trying to build individual models or like, workflows for different types. And I think the point that Milad brought about of, establishing benchmarks, and that's where we learn. I think that's been crucial for us, that, like if you change one part of the system, you may see like, hey, this works great for these types of data sets or like these examples, but probably it's doing worse here. And so, we are kind of following those practices, so that our architects are like, learning and coming up with and like coaching us on and seeing that, what we really need is like a nice curated set of examples that represents the diversity of data that is there in the industry. And then we kind of maintain these benchmarks. So we have a quantitative way of like deciding, are we doing better here, and so it's I think a great time to be an engineer in this field.
Well, it sounds like a lot of these are themes around trust, right? For deterministic operations, for critical environments, you have to be able to trust your inputs and your outputs. And I know since AI has been a thing, people are struggling with black boxes, explainability. They're struggling to trust their data, and I think this is another situation where trust is top of mind for everybody. So for industrial AI agents, how can users trust them? Well, what are some of the developments there?
I was going to say, I could talk to that a little bit, which is, one of the ways that we do that is by providing a large language model with very clear instructions and providing it with very context-laden industrial data, we're able to get far more deterministic responses back from that language model. More importantly, because we're controlling the information that we give to the large language model to answer the question, we also know where it got the answer from. And so we could provide that information back to the user to say, here's the answer I got. And that answer is based on the following source information that you could click into to verify and validate that my answer makes sense to you. And so it's interesting, if you use something like ChatGPT or some of these other chatbots that people have become familiar with, you type in a prompt and you get a response and it came up with something, but you have no idea how it actually came up with that. But when you're using something like an industrial agent, we're actually controlling what information we provide to the large language model to respond to our prompt. And so we're basically telling the large language model, don't answer the question based on what you think you know. Answer the question based on the information I'm giving you. And by doing that, I can also, in the response to the user, say, here's the response that we got. And by the way, here's the data that it used to give you that answer. And so you kind of think about how we use Google search today. I don't know anybody who goes into Google search, types in a few keywords, and the very first response in the list is the one they take as gospel. They go, oh, that's interesting. And let me look at some of these other responses. They go through some process of validation for the response. And in a heavy asset industrial setting, we have to do the same thing. We need to be able to provide users not only an answer that is well reasoned and within the guidelines of what the agent has been instructed to do, but we also give them information and links to that contextualized data that says, here's the information that I used to get that answer so that you can click into that and verify that answer makes sense to me.
Yeah, I want to add to that point, Jason. That's a great point you said of like bringing out like what are your data sources and like making it very transparent. So I think transparency is key here, of like the sources and also what was the reasoning, the agent used. Like, so, being able to showcase like, here are the steps I followed to, achieve this, end goal. And I want to also tie it back to what Milad said about tools. That you wanted your answers to be grounded in data, so you have data from your facility and like Jason, you were saying, this is all, there are like health issues to be taken into account, safety issues, and like environmental impacts of like just arriving at a wrong decision or like making a wrong suggestion here. So I think we have to have guardrails around like how the LLM has to like invoke these like tools to like actually fetch data, to be able to also, show that to the user and say like, oh, this is, by the way, this sensor reading on this pump located in this, this is your facility, the site. And here's what I'm seeing it, and here's what it looked like at 6 a.m. this morning, the data, and it seems like there was a spike here. And are you sure that? And always like keep that engagement with the user. So I guess the user is the, initiator, not the responder here. Like it has to fit into their natural workflow. Like where you take it to them in their normal routine, like how they go about their workflows, and then you are giving that information back. You're making it, all of that data, you're doing all of that work. The agent is doing it and then presenting it to the user and saying, does this look good? Do you have any like suggestions here? And the human is, in control. The user can say, oh, that doesn't look right. Maybe instead go check this tag. Or it could be like, yeah, and I want to now follow it up by filing a report. And so it has to be able to do this, maintain this human in the loop piece. And I think that's like a very important aspect to like establishing trust. And then I'll also tie this back to like the benchmarking piece. Again, I'll keep emphasizing that. I think if we publish benchmarks saying like, again, agents are like designed for specific use cases. So if we can say like, hey, if this is about like understanding maintenance issues in your facility, these are our benchmark results that we've seen. We've seen like with different choices of LLMs, this is what our scores look like, and different types of metrics look like. Then I think then that also brings about that trust that, this is all grounded in data, this is tested, this is validated, and this is, safe for me to consume and to like interact with. And I'm still the one in control and making decisions here.
Well, I know that trust is tied very closely to adoption, right? If you don't trust the outputs, you can't explain, you're not in the loop, why would you ever adopt that into a critical environment, right?
And also like, one point is ultimately it has to bring like value to the business. I mean, people are not going to adopt something just because it's the cool, shiny, new thing. So, they have to see real benefits in terms of it's able to do this much faster, or at least, the time in which I could like build an agent to do this compared to if we had to like set up a team to actually like manually do all this or like write independent like automation workflows. I'm seeing actually this much benefit, like, X% improvement in processes, or additionally, we were able to uncover so many incidents that like without this kind of a workflow, I might not have even gone into this in so much detail. I would be like, yeah, okay, that looks a little off, but maybe it's okay. But now it's easier for me to use this and say, oh, I would not have, maybe I can ask, what was it like at like 6 a.m. and like maybe that will read me down to like more of a getting me more into that troubleshooting mindset, even if I'm, in a rush. So I think, value ultimately.
For sure. Well, I know another thing that's top of mind to everyone is, right, there's this rush to figure out the agents, but what can we learn and what are some of the key strategies around implementation, right? What have y'all seen work so far, and how can we overcome some of these challenges that we've already discussed today?
So, what we've learned early on are sort of threefold strategy. We went into this a little more than a year and a half ago with a couple big assumptions. One, we assumed that just the standard industry-leading large language model would be sufficient. We thought that sort of the standard way that you would retrieve and present proprietary industrial information to a large language model and answering your question was going to work for most use cases. And we thought that the sort of chatbot style interface of ask anything, get any answer would be the framework that most people use. And what we learned that particularly in an industrial setting, we need to be able to use the right foundation model for the task at hand. So we need to be able to use a large language model that is best fit for the task. And Viva was talking about that a little bit through being able to provide some benchmarking information to know what that is. Sometimes you would use a standard off-the-shelf large language model. Sometimes you might use a small language model, which is more efficient and tailored to the activity. And some customers at some point will start having some of their own language models that have been trained on their own proprietary information. So one, you need the flexibility to use the right model for the task. Number two is you really need to provide highly contextualized information to a large language model to get a deterministic response. What that means is these large language models really need context. They need meaning. And so if you provide a large language model with just a bunch of sensor data, it's not going to be able to tell you very much. But if you can provide additional context in the form of incident reports and work orders and other things related to that sensor data, now it's able to use its reasoning engine to provide you some pretty interesting insights. And so being able to leverage a contextualized knowledge graph of your data becomes incredibly important to getting a deterministic response. And then finally, we need to, as we've talked throughout this whole session, rather than having this sort of chatbot, ask anything, get any response, we need to be able to provide specific instructions, access to relevant data, and guidance in terms of how the response should be presented back to the user. And that's what we do within an industrial agent. It's designed for a specific task. And so being able to allow our customers to take advantage of all of these tools to build these agents and take advantage of other off-the-shelf agents that would be available to them is critical. So from an implementation standpoint, you want to be able to use the best language model for the task at hand. You want to be able to take advantage of highly contextualized data to get a deterministic response. And you want the ability to be able to very quickly and efficiently build these industrial agents for these tasks and orchestrate those agents to be able to work together. And so that's what we've learned so far. And we've got some great examples of being able to leverage those capabilities. And, you know, over the coming sessions, we'll discuss the data platform requirements you need, the technologies that are going to enable you to get better accuracy and performance from these agents. And we'll learn how to effectively orchestrate the use of these large language models and pick the right model for the task at hand. And so I think it's going to be pretty fun over the coming weeks to be able to go through these things.
Absolutely. Milad, anything you'd like to add? Anything you've seen from a implementation best practices standpoint?
I think most of it has been covered already. I just want to, again, repeat, having specialized agents is important, both for robustness, but robustness ultimately will also lead to that the user will trust it in a way. If it works, then it will also build trust. And I'm looking forward to go more into the details in the upcoming sessions.
Absolutely. That was the last question I had. I know, Viba, if you've got one last thought you want to leave us with.
Yeah, so no, this was all like great content here, and wanted to add to what Jason was saying in terms of effective implementation. So one point is like, you know, every organization may have their own nuances around like how they do even accomplish a specific use case. So being able to give the power to domain experts so they can, you know, build their own agents and then bring in like their proprietary tools that the, you know, agent can interact with, you know, that is suitable for their data and their workflows. I think that is, you know, that is what we would want to do, you know, for effective implementation here. So yeah, look forward to the following sessions.
Yeah, great. I'm excited to see all your individual sessions here over the next couple weeks. I wanted to just thank you all for the time today. I thought this was a really interesting conversation. I always learn something new when I spend some time with y'all. Next week, we'll be talking through the essential foundations for industrial data, so for industrial agents. So Milad will be leading that session. If the audience has any questions, please submit them to us at contact@cognite.com. We will try to answer these in following segments. And if you're wanting to hear more about how our customers are using and building their AI strategy, we have a great conference coming up called the Impact Conference. It'll be in October this year in Houston, Texas. So consider and join us there. Again, thanks to everyone for their time today, and we'll see you next week.